So this is a composite Simpsons rule. Now in the course I'm teaching it, this is the only version of Simpsons rule we're using, but just for the sake of other viewers, this is just a special variant of the Simpsons rule called the composite Simpsons rule. So essentially I've written out the function here, but I'll just state the full question here. Use Simpsons rule with 4 equal subintervals, that's important, to find an approximation for this integral here, integral from 1 to 2 of the square root of 1 plus e to the x. Okay, something to note here is our interval is the boundaries of this interval, the limits are 1 and 2. Okay, so let's just sort of look at this interval here and look at the 4 subintervals here. So the limits 1 to 2, okay, and we have 4 subintervals, so we have the number line here 1 and 2, and we're going to, the function is evaluated on this range, and what we're going to do is break this up into 4 equal subintervals. So essentially just break it up into 4 parts. So we have these 3 thresholds here, and this is at 1.5, this is at 1.25, this is at 1.75, and so on. So what we've done here is broken our interval up into 4 subintervals of equal length. Okay, so this next bit's important. This is the equation. There's a sort of equation for this. It was actually easier to remember it sort of literally in a verbal sense. So what we're going to do is call this point here, this is the first point, this is the last point. Sorry, this doesn't look like an L. So that's the last point. Okay, this is the first, this is the second point, this is the third point, this is the fourth point. Now this 2 and 4 are even numbers, so this is an even, and necessarily this is an odd. So we have the first, these even values, the odd value, this even point, the odd points, and the last point. What we're going to do is evaluate the function at each of those points, and we're just going to sort of remember how they classify according to this: first, even, odd, or last. Okay. Anyway, that's just a side matter. So just we're just going to come back to that now shortly. So here is the what we have to do is evaluate for each of the 5 points. So I'm just going to give them Roman numerals here. The first point, the second point, the third point, the fourth point, and the fifth point. And what we're going to do is evaluate the function, this function here, which is the integral, what we're looking for, So what we're going to do is evaluate it for each point, of x there that we have listed. So what we're going to do first off is just evaluate the exponential of x. So the exponential of 1 is we'll just keep the 4 decimal places. So 2.7182, or 3 actually would be a bit closer. 1.25, that would be 3.4903. The exponential of 1.5 is 4.4817. Okay, 1.75 is 5.7546, and finally the exponential of 2, that is 7.3890. Now what we're going to do is add 1 to each of those values, rather simple exercise. So this is 3.7183, 4.4903, 5.4817, 6.7546, and 8.3890. Now what we're going to do is get the square root of each of those numbers, and this is again just a bit of calculator work. So the square root of 3.7183, the bit of rounding error is inevitable, so don't worry about it too much. I'm going to write that as 1.928. I've sort of just for this have an answer sheet here that's actually written 3 decimal places. Not too much of a big deal, but I'll just keep going now. So 2.119, 2.341, 2.5898, and 2.896. Okay, so that's the evaluation of the function at each point. Now, what does that do for us? So the composite Simpsons rule, essentially this: the integral is the evaluation for the integral, as the guess of it is h over 3. That's the width of the subintervals. Just remember that the width of the subintervals here was 0.25. Okay, so that there is 0.25. That's the step size, the interval with h, or the subinterval with h. Now what we're going to do is put in our values. Now the sum of the even values and the sum of the odd values. So what we have to do is go back here. So first let's put in the first and last value. Let's do this again on a new page. So this is 0.25 over 3. The first value there, if you look back, was 1.928. The last value there was 2.896. Okay. Now, what we're going to do is 4 times the sum of the evens. So the evens in this case were 2.119 and 2.598. Okay. So 4 times the sum of those, that is equal to plus 4 times 2.119 plus 2.598. Okay, and now 2 times the sum of the odds, and this is the only odd one here. Okay, we don't include the first or last one as an odd in for this algorithm. So this is a 2.341. So what we're going to have here is, there's only one value here, but it could be longer, 2.341. Okay, so that is our integral. Now what we have to do is just compute it out. I make that to be 0.25 over 3 times 4.824, that's just the top line, plus 18.868, that's just 4 times the sum of the evens, plus 4.682, which is 2 times the sum of the odds. Just working that out, the integral will work out to be 2.3645. Okay, so that is the Simpsons rule, 2.3645. So use Simpsons rule to find an approximation for that. So we found an approximation, 2.3645. Okay.